Okay, hello. What I'm going to try to do now is I want to give you a little bit of an opportunity to use this video to help you to get a head start on Part B. We're going to be doing this in class, but I also want to have it here as a support, and I have time to make the video running through Part B right now, so that's what I'm going to do. What I have up on screen is, let me just get rid of this. What I have up on screen currently is where we left off, right? In the assignment, that is this one right here, you can see that, where we had left off in Part A was, you had to go and grab screenshots of different countries. So let's, I'm going to go and grab another screenshot just because I can. It's from this one. Oops. Oh boy, it's from this one. Let's go and grab another country. Let's go to get something. How about something in Central America? As we zoom in, right? The reason why these screenshots are set up is because I want to make sure. Let's see if it'll actually show up. Here we go. I want these screenshots to be your way of proving to me that when you zoom in and out of this project, that the visibility ranges and the label expressions and everything is set up in such a way that it works, right? So here's another one. I'm at a scale of 1 to 1,100,000. Let's go to 1 to 1 million and take another screenshot. This would be an example of El Salvador. I'm going to use the clipping tool just to get this going. I'll do one more, right, as an example, and we can go from there. So I'll grab this and copy it and put it into the Word document, right? So, that's the end of Part A. That's where we're at. And next, we want to go through. So this particular image isn't going to fit. How do I make it fit? Right-click on it. When in doubt, right-click on it. That doesn't just apply to ArcGIS Pro. That applies to, well, a lot of different softwares, especially ones that use a ribbon interface. Right-click and see what your options are. Size and position, that's what I want to change. I was using, I think, 4 centimeters for the height, just to make it small enough to fit, right? There it is. And, I can spread these things out. We need 5 in this box, right? And they could be a little bit larger. You figure out exactly how you want to put these in. There are a lot of other ways to do it, but this is a good way for me to be able to get them inside this box so that I can, capture them and they sit in there and they can be evaluated, right? We talked about these questions, right? We talked about these questions. I'm not going to show you the answers in the video because I want you to go and get those answers. So let's push forward. Those answers can be found in the attribute table of the layers. And what I mean by that is, right, we have all our countries. Well, what if I wanted to look at the attributes of the countries? I just right-clicked on the countries layer and opened up its attributes table, right? So what are some things we could figure out here? Well, we've got country name, and really we just have the area. That's a pretty boring layer. What about the cities layer? What do we have in that attribute table? This data set might be a little bit richer. Sure is. We've got a population class, we've got a population itself. Any other data? Population source. This is all coming from the UN, which that's pretty good, right? So the population, what is the country in the world that has the highest population? If I wanted to sort this descending, that would tell me pretty quickly that, the city. The city with the largest population is Shanghai, China. Okay, so you can get information very quickly using attribute tables. Part B. What is Part B? Well, first off, it says that it's the United States of America. Now, if I were to go to the map and look at the United States of America, it's here, but look at it. It's all like distorted and, the projection that's being used. Remember we were talking about the projection or the coordinate system? And you can go and look at the coordinate system and see that we're using equal Earth, which is a spheroid or a spherical projection, and it makes the globe look like this, which is acceptable for things at a global scale. But once you get down to a national scale, you should really start thinking about modifying the coordinate system of the data for mapping. We don't want North America, or in this case, the United States of America or Canada, to be all distorted and leaning backwards on this spherical kind of map. We've got to change the coordinate system, and that's why there's a different map for Part B. Okay, Part B, I've got to get my catalog pane back. No big deal, use the View tab. When I get my catalog pane back, you'll see that there's a map called United States. I'm going to drag that in to the project. Or actually, sorry, I can't. I've got to just open it. It's not a layer, it's a map. Maps are different. Maps are views. They're not layers. So you can right-click and open the United States view, and you see that, oh, okay, well, I've got this world terrain base image, and North America looks different, right? Look at North America here. It's kind of leaning, and then if you look at North America here, it's kind of standing up a little bit taller. They're both projected on a flat surface. That's why they're called projected. The coordinate system is being projected so that it can be viewed on a flat surface, right? When you use a projector in a room, it projects it onto a flat wall. Same idea, right? Coordinate systems can be projected, and they can also be geographic, right? If you were using a GPS in the field and using, decimal degrees or degrees, minutes, seconds, or, and working in a geographic coordinate system, what you're doing there is everything is working on a spheroid. You can view things in a geographic projection, or a geographic coordinate system as well, sorry. But our United States map is actually in a projection that looks like this. Look at this. Look at the way the world works, or looks now. Totally different from the world equal Earth projection. What is this projection? It looks pretty cool because it's like centered on North America. I like it. Well, what is it? We can go and check. I'm going to right click on the world, or sorry, the United States. We're in the United States map now, and check its properties. I go there and we'll see that, oh, now we're using what's called an equidistant conic projection. It's in North America. It's a continental projection. And what's the WKID on this one? It's going to be different. 2010. 102010. That is the unique WKID for this particular coordinate system. And the coordinate system is called North America Equidistant Conic. That's a long name. Well, that's it. The WKID is 102010. Can I copy that out? I hope so. That's okay. It doesn't look like it can. Whatever. Do I need to put that into the Word document? I sure do. 102010. I'll give you that one. That's a gimme. If you want to know what a WKID is, right, there is a link right here that'll help you. If I were to click on that link, it's going to bring me to an epsg.io. It's a website that talks about all of the different coordinate systems, right? So this is a North American continental equidistant conic projection, and it shows you all the parameters and so on. So all the WKIDs, right, are listed, and they're all part of this website. You can look up all of them and find out what the transformations are. You can find out exactly how they are, all the descriptions for them, and so on. So they're really interesting, and it's really important to think about coordinate systems as a way of representing your data, right? What kind of coordinate system are you using, right? Are you using a global or a world-based coordinate system? Are you actually wanting to be centered on a continent so that everything that's inside of the boundaries of that continent sits nice and flat, right? Do you want to preserve distance? Do you want to preserve area? Do you want to preserve direction? Do you want to preserve shape? Pretty important stuff when you're mapping. Anyhow, that's that. So actually, as you zoom in to larger scales, right, even this continental coordinate system can start to fail. As you get into regional or even local larger scales, your accuracy is going to start to go out the window. And there are other coordinate systems that will come into play that will help you to be more accurate in your mapping, and also allow you to measure distance, direction, area, and things like that more accurately as well. Okay, so it's all scale driven. It's all coordinate based driven stuff. So that's the coordinate system we're going to use for a national layer, or a national group of layers that are found. Well, they're not found in this map right now, but they're going to be as soon as we use the geodatabase that goes with this map. Not the World Geodatabase. Let's just hide it, and let's open up and see what's inside the national United States GDB. We've got a national featured data set, and then we've got USA Parks and a UTM grid. Whoa, what's that UTM grid for? UTM is a way, it's more of a regional approach. It's a larger scale coordinate system that divides the world, or the globe, up into these tiny little slivers, widthwise. And if you're inside of a UTM zone, you can be very accurate. It's a Cartesian coordinate system, it's a projected coordinate system, and you can be extremely accurate with it. Okay, that's how I'm handling this to describe coordinate systems right now, because we haven't really touched on a lot of theory behind coordinate systems, and that's going to be happening over the next week or so. But this is kind of like an introduction and working with layers that are in different coordinate systems. It's really important to always have your layers line up. Like, look at what happens. I zoom out a little bit, and look at how slow this world terrain base is drawing. It's horrible. It shouldn't be taking that long. The reason why it's taking that long is because the map, we just looked, the coordinate system of the map is the equidistant conic coordinate system, right, the North American one, and the world terrain base. This is a base map. All of the base maps that Esri provides, right, for throwing in the background, they're not layers, they're base maps. They have their own coordinate systems. If you look at the source, you look at the spatial reference, this is in Web Mercator. WGS84 Web Mercator is the coordinate system that is used in Google Maps, Bing Maps. It's also the one that Esri uses. Esri wants you to use the Web Mercator, because that's what all of the base maps are projected into, or that's the coordinate system of all the base maps. If you want to use a base map, your data should be in Web Mercator if you want to be doing mapping. Okay, that's just the way it goes. And if I were to change the coordinate system of this data frame right now, because you can do that, right? You can just modify it. You can say, well, instead of using equidistant conic, let's flip it over to whatever. Well, let's see what the coordinate system of my layers are. Right? I'm in the map properties, and if I wanted to see, my layers are in Web Mercator. Now remember how slow it drew, or how slow it refreshed, forcing that base map to be refreshed in the equidistant conic coordinate system? Well, if I flip the map over to match the coordinate system of the base map that's in it right now, this world terrain, watch what happens. Boom. And it took less than a second to draw. I can zoom in and zoom out. And also, look at the shape. It's nice and flat, everything stands up nice and tall. This coordinate system is great, and it should be familiar, right? It should be familiar because, Google Maps and that will use this coordinate system, or they do use this coordinate system. So look, there's more to it. There's a lot more to it, right? Because as you zoom out, you start to see things like, look at the size of Greenland, and there's we're going to watch some videos that explain all of the shape preservation and distance and direction preservation and area preservation and distance direction preservation stuff. So right now, what we're trying to do is we're trying to work with this map. And the problem is that if I go to Web Mercator, North America looks great. It looks awesome. I'm happy with it, right? And it zooms in and out really quickly. But we have data in this feature data set over here that's in the United States GDB. If I go and check the properties of that feature data set that has all of the feature classes in it, and look at the spatial reference there, well, this is all in that North America equidistant conic coordinate system. It's projected, great. But what happens if I try to add this stuff? Now I'm going to have another mismatch. Now I've got to wait for it to draw. It's a little bit slow. The reason why this data is drawing slow right now is not because of the base map. And what happened to our map? The base map doesn't control the coordinate system, the layers do. Look, now the map automatically got switched back to the equidistant conic coordinate system. That goes to tell you that the base map that was in there was not controlling the coordinate system of the map frame or the map view. As soon as you add a feature class and turn it into a feature layer because it's being displayed in the map view, it will modify the coordinate system of the map view to match itself to the map view. But now, the mismatch that we have going on is that this world terrain base, right here, is what's slowing things down, right? We zoom out and we've got to wait for it to draw. I don't like that. I don't like that one bit. So you know what? Get rid of it. Gone. Look at how quickly it drew now. I zoom in, boom, done. Zoom in, boom, done. Right? That's what we want. We want it to be snappy. Pardon my enthusiasm, but that's exactly what we want. We don't want to sit and wait for the thing to draw. Okay? A lot to go through there. And basically all you do when you bring in layers to your map is you want to make sure that the map view, by going to its properties, you can see its coordinate system. You want to make sure that the map is in a matching coordinate system to the layers. And you can see that the map itself is there and the layers that are in the map are in the same coordinate system. It's a lovely, lovely thing. Okay? And when you are matching things up that way, things draw nicely and the software functions as it was meant to. There is a transition happening in the mapping world where, at least on the national scale, if you want a base map in the background, the base maps that are provided by Esri, you got to use Web Mercator. That's just the way it goes. Or you got to wait for it to draw. It's a drawback. Oh boy. So that's it. Okay. Let's go back over to the document and let's have a look and see what we're up against as far as the exercise. It says here it's been kept in the map view to provide an example of a different projection being used. Notice that the refresh rate is slow. It's because the coordinate system, right, of the base map is 3857. That's Web Mercator. Okay, and this WKID up here, that's your North America equidistant conic. In this exercise, I'm at number 3 right now. In this exercise, the United States GDB is the data source, right? We just added the feature class in, so we're good. It's listed as one of the available geodatabases. Drag and drop the national feature data set into the contents pane to add all of its feature classes simultaneously. Perfect. We did that. The United States map feature layers should look familiar. They were used in the last lab. Quite often, data sources are common across multiple projects. It's true. They could be sourced from a static external directory. And what I'm trying to say in this number 4 here is that quite often projects that you are using to map out, using different themes or storylines or when you're trying to say something or map something out, right? The data itself can be from an external source. And as long as that external source stays in the same place, you can always use a project, an APRX, to point to it, right? The problem is that if you move that data, the APRX won't be able to find the data anymore and you're going to get problems. So what we've been doing so far in this course is we've been giving you the data within a project folder, and it's able to find everything and everything's fine, right? No big deal. In this case, a copy of the United States GDP has been included within the project folder and modified slightly to include a feature data set. The national feature data set includes the same feature classes, or at least a copy of them from compared to the last Lab 1 stuff. And in this exercise, there's going to be new feature data sets created. So here's the thing, right? We've got a geodatabase set up, and there's a feature data set within it that's just called national. Well, what if we wanted to create or subset data for individual states? What would we do, right? Well, if you have a state, say Texas or Arkansas or South Carolina, whatever, and you wanted to subset data and just focus on an individual state by itself, all of a sudden you could think of things like, oh, well, maybe there's counties there, or maybe there's school districts there, or maybe there's protected areas, or there's a lot more data that could be brought in at a larger scale, and you could have regional or local information brought in and mapped out that isn't technically mappable at a smaller scale. Like the national scale, you don't want to start trying to bring in, all of this extra data and just throw it all on the map because of the spaghetti factory factor, right? Yeah, sure, throw all the data in there, but you're not going to be able to see it because ArcGIS Pro is all it's trying to do is just display it, right? And change colors of things and symbolize things in order to say something. Have a theme, a thematic map, a choropleth, right? There's also isopleths that we're going to talk about later in the course, but a choropleth map is a thematic map that's trying to say something statistically, right? Like you might be trying to talk about population density, or maybe you want to get into demographics, or maybe you want to talk about habitat, or forest resource information, right? There's a lot that you can talk about with a mapping application that can modify colors and chart things out and display statistics and all of that. But you've got to understand how it all works. And part of representing your data is lining up your coordinate systems based on the scale that you're working at. Super important. You don't want to be trying to say too much about too many places because it's just overwhelming for whoever you're making the map for, right? Be specific and deliberate about what you do. So in this exercise, there's going to be new feature data sets created for individual states to keep things organized and proper, right? Open the state's feature layer attribute table and view its contents. Answer the questions in the table below to get acquainted with the available information. So you're going to get 5 marks just for answering these questions, right? So what subregion does the state of Texas belong to? What's the total population of males within the New England subregion? Whoa, what? How are we going to even figure this out? You got to look at the attribute tables. You might have to sort ascending or descending, or maybe you could do a query, kind of like a definition query, but where you're querying the attributes, okay? How many states are found within the West South Central subregion? If somebody came and asked me that just on the street, I wouldn't know what to say. But if you've got access to the info and you've got an application like ArcGIS Pro that can work with attributes the way it does, I can get you that answer in like 0.2 seconds, no problem. You want to know? I can tell you, because I have the access to the data. There it be. So which state has the greatest proportion, of vacant homes per capita? That's a difficult one to answer as well. You're going to need to know what the proportion of something is. That means, vacant homes per population. Whoa. These are hard questions to answer, but they're important because these questions are getting you to start thinking about data spatially. So taking that information that's collected and saying, I'm going to spread this across a state, or I'm going to spread this across a county, right? These sorts of questions could be mapped out across the United States, right? Or we could be using Canadian data right now as well, and we are actually, after we're done this lab, we're moving over to Canada and Ontario, and we're going to start working in those regions. But right now, we're working with the U.S. Census Bureau data because there's some really fun statistics there. Did I say fun statistics? Yes, I did. So we have to symbolize all the layers in the map using a simple single symbol color patch. And there's a table that I say is at right here. I apologize because the table is actually below. It started at right, but then it moved. We have to modify the legend patch shape of each feature layer using the table below. So that's the patch shape, no big deal. It tells you which shape to use, no big deal. We'll show you how to do that. We have to create a definition query. Oh boy, we're going to have to get into the nitty-gritty of this data that we have up on screen. What data are we talking about? Well, here I am. I've got the United States map open. I'm going to close the Mundo map and just leave the States map open, right? We don't need the Mundo map anymore because we've pushed on beyond Part A. So here it is. I don't even know where I am right now. Okay, here I am. What am I looking at? What is the data? What data do we have? Whoa. All right, so we don't have all of the states. We're missing Puerto Rico. We're missing the Virgin Islands. Whatever, that's okay. We actually don't want, we're going to exclude Alaska. We're going to exclude Hawaii using definition queries. And we're going to deal with all of these layers and try to make this US data set look halfway decent. And then we're also going to look at UTM zones, right? Because the United States of America covers quite a few UTM zones. And what I mean by that is I have this other layer here called the UTM grid. This is a grid that is global, and when I bring it in, I'm going to drag it down to the bottom so you can see what I mean. I know that's a little bit hard on the eyes, but what's going on here is you can see that the United States of America are found in all of these stripes that run from the North Pole down towards the equator, right? Once you get to the equator, then it flips to the south, right? The southern hemisphere. So everything from the equator up is in the northern hemisphere, and obviously the United States is in the northern hemisphere, and here we are. So, you know, Alaska is over here, and you can see that Alaska is it's a huge state. It looks way bigger than it actually is here because of the projection that's being used, but we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 different UTM zones just for a single state. If everybody that's here looking at this very likely has used a GPS unit, and if you were using a GPS unit and you were using a projected coordinate system or a Cartesian coordinate system with that GPS unit, you would have been told that you had to use a UTM zone as your base, and you would be working inside of a UTM zone, right? So what are all these UTM zones? Let's label the UTM grid and just kind of have a look. That doesn't look right. Those aren't the right labels. So remember, if I have the UTM grid layer selected, I can go to its labels and define where these labels are coming from. Let's go to zone, and you'll see that here it is. So UTM 1 all the way over to UTM 9. Right? Ontario and Sault Ste. Marie is found in UTM 16, UTM 17. Right? Ontario itself actually goes from UTM 15 all the way over to UTM 18. And there are different states, and we're going to be looking at those. Okay, so I'm going to close off the UTM grid for now, and we're going to come back to it. Right, so we need to create a definition query in the states and counties feature layers. So 2 different layers, and we need to limit the view to not include Alaska and Hawaii. Hint, hint. Activate the states in the contents pane and select the data tab in the ribbon to access the definition queries. And then use the state name field in a Boolean argument to get rid of all of the states that are not part of the lower 48, or at least the conterminous states, right? The lower 48. How are we going to do that? Well, let's start with the states layer. The states layer, what I want to do is get my data tab and set a definition query and get a new definition query, and I'm going to say state name is not equal to Alaska. Is that going to make Alaska disappear? Let's try it out. Let's see. Did Alaska go away? Yeah, it did. But it didn't go away on the county level, right? See how we've got the counties layer is pink? These are all of the counties in Alaska. They're still there. So let's go and put the same definition query on the counties layer. State name not equal to Alaska. I'm just going to click OK. It should disappear. There, it's gone. Bye-bye. No more Alaska. But we got to do the same for Hawaii. Right? So I'm going to do that real quick on the states layer. I'm going to go to my definition query. It says here edit. Well, sure. Let's add a clause. Meaning, if state name is not equal to Alaska, can I do state name is not equal to Alaska and state name is not equal to Hawaii? So that everything that's not Alaska and everything that's not Hawaii gets displayed? That's what I want. So let's add a clause and say, and state name is also not equal to Hawaii. I'll apply that. Hawaii should go away, but I have to do it on the counties layer as well. Right? Add a clause, and state name is also not equal to Hawaii. Where is Hawaii? There it is. I click OK. Now Hawaii's gone. What about the cities layer? Let's look at the attribute table and see if maybe, do we have a state? State FIPS, state. Oh, we've got a code. Oh, this might be a little bit more difficult. We can do it. Just requires a little bit of brain power, that's all. The code for Alaska, what is it? AK, Anchorage is in Alaska, so the state, this right here, this ST field, is saying that AK, what about Hawaii? It's probably going to be an H, you would think, right? Of all of the cities, let's go down to where the H field is. Come on. This is a ridiculous way of trying to get it, but it is what it is. You can fast forward this part. Lots of cities in Florida. Lots of oh, what's this? HI. Right there. These look like they're part of Hawaii. So HI. Alright, let's do a definition query on the cities layer. I'll get rid of those ones. Let's go ST is not equal to AK and ST is not equal to HI. Boom. Bye-bye cities. I'm still stuck though. Where are these? I got a roads layer. Do we have an ST field on the roads layer? Nope. Now, there are ways of getting rid of those as well, but I think you get the idea, right? We've cleaned up our data set, and now we can focus just on the lower 48. Okay, that's the point of all of this. We've done that. Do we need a screenshot? No, not yet. We gotta change the representation, change the appearance of all of this stuff using the table, right? find the UTM grid feature class and drag it from the catalog pane to the drawing order. And it's going to be an addition, and we want to use the table below to set all the parameters that are required to modify the representation of the layers at varying scales. So there's going to be some visibility range stuff happening here as well. So let's start with the cities. They're going to be on top. Obviously it's not applicable to have a symbol patch shape or a legend patch showing up, but we want the cities to be 2 point. We're going to use a square and they're going to be black. Let's get that done. Cities. Remember when you just click on this little patch here, we get our symbology pane? How do we make it square? Let's go over to the gallery. See the properties versus the gallery. This is for the symbol itself. It's not primary symbology. Primary symbology happens when you click on the name of the layer in the table of contents. That's where you can go unique values or graduated symbols for a point layer. We will be playing around with that. I think I was supposed to do that for the world layer. We're going to have to do that in class. I apologize. Anyways, the cities themselves, we need to click on the shape, right? This symbol patch. And we want to go to the gallery and find a square. There's a square right there. It's black. Okay, those are way too huge. Go to the properties and modify that. What size do we want? Not 10, we want 2. What does that do? If I apply it, there we go. A little smaller. Right? You can. I'm not really too concerned of whether or not you use, maybe a color that's not as aggressive. We're not going to use an outline color. Leave that at 0 and let it be that. Now, what about other things? Outline and thickness. 0 point on the thickness, so we got that. Visibility range. Okay, so if we're out beyond 1 to 20 million, we want the cities to disappear. Let's go and take care of that. Cities is selected in the contents pane, and up in the top we've got our different ways of accessing either the appearance, labeling, or data for this feature layer that's selected in the contents pane, which is the cities. So let's go over to the appearance, and if we're going to make the visibility range so that these symbols or these cities disappear outside or out beyond 1 to 20 million, well, that's right here. Let's go 1 to 20 million. They're still there. Why? Well, look at the scale. I'm at 1 to 18 million right now. If I go to 20 million, oh, they're still there. If I go to 20 million and 1, bye-bye. So it's working, right? As you zoom in, they should appear. There they are. Okay? That is important. We are going to master that skill, setting visibility ranges. The labels. We want the labels. Oh boy, what is happening now? We want to turn the labels on. We want the labels to come from the name field. We want the visibility of the layers of the labels to. It's got to disappear once you zoom out beyond 1 to 10 million. That's fine. But this is something new. We've got a label expression right here. It says here that the POP 2014 field greater than 500,000. What we want to do is we want the labels to only show on the features that have attributes in the POP 2014 field greater than 500,000. So only cities that have populations greater than 500,000 are to be labeled. Okay? Let's try that out. And we'll do a definition query on this layer shortly. So let's go back to our map. Number 1, turn on the labels. Let's see what happens. Let's see what we get. We're going to get a lot of them. Too many. We don't want that. So, The label field is name already. I think that was the default. We want the labels to disappear outside of 1 to 10 million. Okay, we can do that. So for the labels, we go to the label tab, out beyond 1 to 10 million. Right, so let's zoom out beyond 1 to 10. The labels should disappear. They do. Perfect. But we're not there yet. We're also going to set a definition query on this layer. Let's go, let's see what else we have first. We also, want to limit the labels so that only cities that have a population greater than 500,000 are labeled. So that's going to reduce the number of labels and make our map have less of the spaghetti factory factor going on. So let's go in here. We've got cities, and for the labeling tab, we're going to create an expression, a label expression. We did that with the world geodatabase stuff in part A. So let's go to this query, and let's set it. I'm going to use SQL because I like the drop downs. They're easy to understand. Right? So where pop 2014 is greater than 500,000. Let me just type that in. If I apply that, what's going to happen is this is being applied on the labels. Right, so when I zoom in to where the labels are supposed to be visible, only the cities that have populations greater than 500,000 are going to be labeled. Look at that. Milwaukee, Chicago, right? There aren't going to be very many around here. Probably Detroit. Yeah, right? So there it is. And when I zoom out beyond 1 to 5 million, I'm still getting these labels. But look, it still is busy. I don't like that. It still is busy. I'm going to go to a little bit less gray. I'll leave them at 10 point for now. But now all these little tiny squares, when I'm out here beyond 1 to 5 million, I'm not liking that. So let's reduce the number of labels that are actually the number of features that are even visible using a definition query based on population as well. We don't need to see all these tiny little towns because it's just too much. It's too busy. And this is all, you could if you wanted to, but for this exercise, we are learning how to set limits on features using definition queries, label expressions, and so on. So let's use our brains now and think of a way to reduce the number of these little squares that are all over the place using some attributes, right? Because that's what a definition query or a label expression will do. I only want to see those little black squares for cities that have a population greater than 250,000, and I only want to label the ones that have a population greater than 500,000. We can do that. How? Well, for the appearance of this layer, we only want the squares to show up for cities that have a population greater than 250,000. Well, we set the visibility range for the layer to only show up, outside of 1 to 20 million, but in the data, we can go and do an exclusion or a definition query to exclude anything that's less than 250,000. Right? We're already excluding Alaska and Hawaii cities. Let's go and add another query, query number 2, and we're going to go pop 2014 is greater than or equal to, sure. I'm going to go 250K, or 250,000. If I apply that, then what's going to happen is, regardless of what scale we're at, we're not going to see cities that have populations less than 250,000. I hit OK. They're all going to disappear, and now there's fewer of them. Of course, around Chicago, there's tons of them. Wait. And they disappear as you go out. Something may not be right here. Did I get it backwards? Let's check. POP 2014, this one only has a population of 18,000. Something's not right in my query. Let's go back and look. Quite often when you're using Boolean expressions, right, this can happen. The POP 2014 is greater than or equal to 250. Maybe I had to turn it on. There it is. See that? So not only when you're doing definition queries do you have to assign them, you also have to turn them on. Okay? You should be able to have 2 on at a time. Let me just see something. Did Alaska come back? No. We're good. Okay. So there it is. The cities have been set up so that, let me turn off all the layers except for, let me get rid of all of the other layers. And look at how nice that looks when you're zoomed out. There's no labels right now because we're outside of 1 to 10 million. If I go into 8 million, I should get labels on all of the cities that are that have populations greater than 500,000. It's lovely, right? It works really well. All of that data is still available to us. It's just what's being displayed. What we're controlling is the representation, the appearance, and we're also controlling how much information is being displayed as well using definition queries and label expressions. That's the key to this. That's the importance, right? So, in this lab, we've got coordinate systems that are, warping the data into different shapes and, all of that. That's one way of controlling representation, is using a different projection based on the scale of the data you have. And then you can start to get into definition queries, label expressions, changing the colors of things and making it look fancy. Did I say fancy? I did. There it be. So, in the catalog pane, there's not really a lot left for me to bring in yet. There is a USA Parks layer, but let's not deal with it yet. I'm just going to close off my catalog pane. This pop-up, right? Remember how when you can just click on stuff and you can get some information, right? I have this map set up so that when you are using the Explore tool and just clicking on stuff, it tells you information. And I have it set up so that anything that is selectable, or even anything that is visible, will show up here. This is Nebraska. There it is. And we just clicked on Valley County in Nebraska. Well, I can't even see the counties because the states are in the way. If I drag the states below the counties layer, remember, drawing order? If I drag this down, now we see all the counties. Well, how do we make it so that we can see the counties and the states? Well, I could bring the states up, and I could make them hollow. We were doing that with the world stuff, right? And I could make this a little bit thicker, right? I could do that, where we can see the state boundaries, plus we can see all of the counties. No problem. That's fun. These data sets are fun to play around with because, the United States is relatively familiar data, and it's fun to look at all of the data that we have here. Of course, it's a video, and I'm not going to be, zooming way in and doing all this stuff yet, but our goal today is to get ourselves to a point where we can decide we're going to look for, just an individual state. We're going to pick one. And we're going to say that's going to be the state that I pick, and I'm going to use a different coordinate system, create a new feature data set for it, and I'm going to use that coordinate system for that feature data set, and we're going to focus on just a single state. We're not there yet. The roads layer needs to have a legend patch of zigzag. We are going to try a display filter. We could do that. And we're going to play around with poinsettia red for all of the roads. And we are going to play around with a description, the name, or the labels are going to be the description field. And we don't want to see the labels out beyond 1 to 1 million. That's a much larger scale. In other words, there's so many roads in the United States that it doesn't make sense to be throwing labels on them when you're zoomed out beyond 1 to 1 million, because it's just, you get a spaghetti factory. And we're not going to put a definition query on this layer. So let's go and take the... Oh, and for the labels, we're only going to label the interstates. Cool. So on the states layer, or sorry, on the roads layer, let's turn them on. Lots of roads, right? What color are they supposed to be? Poinsettia red, right? No problemo. Poinsettia red, where is that? So let me select the roads layer. Look at the symbol patch. Let's change its shape. Remember we're supposed to use zigzag? Which one is zigzag? Probably the one that looks like this, right? There, now we've got a zigzag in our contents pane, and we can move onwards. Let's change the color. So we're going to change the color properties, and we're going to choose poinsettia red, rose, medium coral light, Mars red. There's poinsettia red. My wife Deanna, her grandma, her mamère, would say poinsettia. There it be. So let's take this and go to 0.8. See what happens. Oh, nothing happens. Why? Well, we got to apply it. Everything's poinsettia red. I'm going to turn off the counties because they're distracting me. So the roads, there they are. Now, is there a way to put a display filter on these so I don't see all of the roads? Maybe in the primary symbology. Oh, what's this? Display filters. If we enable this, what does that mean? Currently we have a display filter that's just showing you everything and making them all red. What if I were to add a display filter? Right here, this new filter, and set up a query. What if I were to do that? Or what if I were to set it up so that the way that the features are displayed changes when you zoom in? So when I have this new filter activated, what if I wanted to go and change the primary symbology to unique values based on, I guess, description? How about highway type? We've got arterials, freeways, interstates, unclassified. Right? What if I wanted to take my interstates and make them poinsettia red? And 0.8. I'll apply that. Now let's go back. Let's go arterial, all of these others. How about I go back to the primary symbology where I have all of the different classes? What if I just remove all of them? I'll leave the freeways in, because they're kind of like interstates too. What if I did that, and what if all of the other values, I gave them just black? Or dark, and really thin. Alright, see how the display is being filtered or changed right now? The freeways, let's make them 0.8 and poinsettia red. Now we're getting close, okay? And it's a good idea to just give me one moment. I'm going to pause. I've got somebody knocking at the door.